Another example, more realistic, right? A little depressing side, but bone marrow transplants.
I don't know. He's figuring it out.
We do talk about bone marrow transplants, and siblings. They use siblings to fight cancer, bone marrow cancer, by doing bone marrow transplants. But you have to be a match. And it's easier to have your sibling be a match, right, than other random people for bone marrow transplants, right? So they use your siblings to be able to, right, replace that bone marrow if you don't have it, right? So in this case, we're talking about this brother who has cancer in the bone marrow, and the brother has 4 siblings, and we want to calculate some probabilities. So I don't know if this number is true, but bone marrow match is independent, is something they're saying, and it's 25% of the time it could be a match if you're a sibling. So there's a probability that's associated with it. I don't know if that number is true. I don't know what the number is for bone marrow transplant, but if we had that number, we could use it, right? And it'd be the same mathematics that we would here. And they do these studies in science. All right. So what is the probability that all 4 siblings were bone marrow matches? So, yeah, so all 4 siblings. Siblings, I could write sibling, and sibling, right? It is an and statement, just to make that clear, right? It's sibling and that sibling and all 4 siblings have to be the bone marrow transplant to fit this scenario that I want. Do I need that scenario? Probably not. Okay. But all 4 siblings, being this is that probability of 1 sibling. I'm getting there. Hold on.
Okay. Sorry.
Maybe I think I need an S. S equals sibling, right?
S equals sibling, yes.
Sibling, if I can spell it. I don't know why I'm having a problem with spelling. So this would be the probability of S and S and S sand, and I'm just gonna start going with what Perry said.
What?
Put that and symbol.
It
looked like sand. That's the problem. I can't do it.
We get it. It's okay. Do your best. There you go. Boom. You did it.
There we go.
Now it looks like S's.
No, S's and S. There we go. I tried my best. Gave you my best and symbol. That first one's horrible.
You'll have to start somewhere.
Thank you. So, right, so there's the and statement, but it is independent, which means I'm going to take the probability of 1 sibling, which is 0.25, and raise it to the 4th power, because I have 4 siblings total. That's 4 times 0.25. So what's 2.25 to the 4th power? Something else. So, I don't know. No, it's something really bad. 0.0 what? 0039? 3 zeros or 2 zeros? Sorry. I hate it when I write too many. 39? Like that? Anybody else getting that?
I just needed it.
Yeah. Somebody said yes. So basically, what, 0.4% of the time you can get all siblings to be a match? All 4 siblings to be a match? But he doesn't need that. That's too much for what he needs. So let's calculate the probability that none of the siblings were a match. We definitely don't want that, but let's calculate that probability anyways. So using the notation, this would be the probability that 1 sibling is not a match. Do you get the notation? There's that prime we were talking about. Complement set. Oh gosh, I got to do the and symbol again.
Think about this when you assign homework. There you go.
Why am I having such a hard time with the and symbol? I don't know.
You're doing the best you can.
Did we get that statement? Not a bone marrow transplant. not a bone marrow match, not a bone marrow match, not a bone marrow match, not a bone marrow match. All 4 siblings are not bone marrow matches. So this would be, what would that be? What is the probability? So this would be the probability that you're not a bone marrow match raised to the 4th power. But what is the probability that you're not a bone marrow match?
0
Not 0.
or
0.75. 0.75 raised to the 4th. What did we just use there? What rule did I just use? To find 0.75. That's the complement set.
Yeah.
That's the complement idea, right? We used it right there, right? Right inside there. First, let's see about the next problem. Because I don't really want either of those problems. That does me no good if I'm the brother. Right? That does me absolutely no good. Right? Well, I guess knowing all 4 siblings were a match would be good, but I mean, it kind of scares me that I only got like 0.4 of a chance to get that bone marrow. That's what that kind of saying. That's not good enough. It's got to be better. Because I really just want one sibling. All I need is one sibling to do it. But I could have 2 siblings as well. I could have 3 siblings. I could have 4 siblings. That's okay. If they're all, right, good. If they're 2 are good. Right? If 3 are good. You get why I'm saying that? There's options here. So there's so many options, it's hard to calculate the probability because I could have that first person, my first sibling, being the bone marrow match. Or I could have the second person being, don't hold up that finger, I could have the second person being the bone marrow match, the third person being the bone marrow, or the 4th person, and then I could have 2 of them, and I could mix those up. There's so many or statements, it's just too hard for even me to think about calculating those probabilities of or statements. So let's use the complement space. It's awesome.
I just have a quick question just before we move forward. I just want to make sure I understand how you're getting that 0.25. You got that 0.25 because
I was given that.
you were given that? Hold on, I'm sorry. Oh, you
25%.
You sure were. You sure dang gone were. Okay, sorry. I totally missed
All
that.
right.
Thank you.
So now let's calculate the probability that at least one,
Okay.
at least one sibling, 1s, which is also equal to the probability 1 minus the probability of none. You see that at least one statement, you are doing this, all right? That's your go-to method. You see at least one anywhere on the problem, you already are assuming 1 minus the probability of none is what you're going to use, all right? So, what is my probability of none? Oh, we didn't find it.
No.
we didn't actually find it. We didn't do that 0.75 to the 4th power. Sorry.
All right.
What is that?
We're not gonna do it then. We'll just do it later.
0.33. 3. Let's do 3.1. Let's use 3.1. Let's go in the middle. 3.16.
Okay, boom.
So I'm gonna take away 1 minus basically 31.6%, which would be, can I do the math? 6, 8, 4. Yeah? 68.4% of the time. Yes! That's much better probability. So I went, sorry, I had forgotten to calculate, right? What that 4th power was, so we did that, and we came back to put that in place. I subtracted in my head, yeah. 1 minus that. I used GeoGebra in my head.
I didn't understand this.
Yeah, that's.
Okay, so I'm gonna just speak in terms of like how I'm seeing it on here. What's my none like in this problem? My none in this problem is.
Your none is the probability of no sibling having the bone marrow
I'm
match.
sorry, so my none underneath is my 0.316, is that my
Yes.
none?
Yes.
Okay, cool.
So
And
what
then-
we just calculated above is what we needed for the problem.
Got you.
Right. That was the reason we actually calculated it, though I didn't tell you. There was no reason I needed to calculate that except for this
Okay.
understanding that we needed at least one. And this is the true probability I need to happen for
Okay.
me, which is 68.4% of the time. I could expect one of my four siblings, at least one of my four siblings, to be a match for me. Those are good odds, right? Those are good odds.
So
if you want to count too.
Sorry, Evelyn had a question.
Where you get the 0.7?
0 point what?
7%.
So that was the complement space of the 25%? Because 25% of the time, one sibling will be a match. So 75% of the time, that sibling will not be a match. Emily?
So, let's say we get the decimal, so let's say if we want to get percentage, so we just times 100 to get the percentage.
Yeah, you could use 100%. Is that what
No,
you said?
like, let's say if you talk to somebody, you're not gonna talk about decimal, right? You're gonna talk about the percentage, like
Yeah.
what's the percentage of each sibling that will have to match.
Oh.
So that would be
Yeah.
just time 100.
That's what I'm doing, right? I'm changing it with my words, 4%. So I'm changing it with my words, but I'm not writing it down. A lot of times we don't do that, just because there's no point in this. We're just trying to make sure we understand the math, right? On the test, you give me the decimal. There's really no point to change the percentage unless I ask for it. So I'm assuming we know how to change this. No.
just trying to understand how it all fits together. So in order to find my complementary set, I need to first find my all set. I'm trying to figure out how we figure this whole thing out. So if I'm given this problem, probably the easiest place to start would be the all thing. And then from there, I find my complementary, and then the result is my.
So
my
the all
none.
statement had nothing to do with these next two ones, so.
Well, the all statement kind of does, because from there I found my complementary set rather easily. The 0.25, I looked at that and I was like, you're asking for the complementary set, so naturally it's 0.75.
No, this is the probability of the first one.
Okay, so I didn't need to do that first one to
The
find.
first one was just an extra problem.
Okay.
That was just me talking about what's important and what's not
So
really,
how
so
would
this
we
wasn't
find the
important.
complementary set of that? Because don't we need
Right
to
here,
find the
how do we find the 0.75? By understanding that one sibling being a bone marrow match is 25%.
Oh, got you. Okay, so we can just look at
So
the
one
problem and
sibling
get
not.
that, and then once we get that, the result of that is what we use for our P.
Yes.
Is our, so we need
P of
those
none.
two. Those two go together.
I'm using the complement set twice here.
Okay.
I am. Yeah, really.
Is there any difference between, so there's like two formulas for that?
There's none. None, yeah. Done?
I had a question. So, how did we get from 0.75 to 0.316? That part I'm a little lost on.
0.75 to point.
316.
We raised it to the fourth power.
Yeah.
Okay, we raised it up to the fourth power.
And that's what that result was.
Okay.
So just doing a GeoGebra, doing a calculator, you should see that.
Okay.
All right. All right. So here's the rub. I need to move on. Around with these. I want you to play around with your homework because it's due on Monday too. Okay. So play around with your homework. There are some at least one statements. Again, if you see that at least one anywhere in there, the problem, you're thinking of one minus the none. Okay. And what that means. Yeah.
They come out online homework or like the rest of the exam?
Yeah, just try those out, right? Make sure you kind of hit those, right? I'll throw out some solutions for these two
Okay.
in my colleague's nice writing, so you can kind of check them out. I'm not gonna make it due, just because I'm getting flustered with everything that's been going on. So, and I should say also, there's been some things due lately. If you didn't turn them in, just turn them in when you get a chance, okay? I'm just gonna leave it open because of all the issues that's been going on, all right?
You just have some homework that it like shows like when you
Yeah,
go
I emailed you back.
Well, when you go into like the homework, like this open stack, and then it says stuff is due, but then like I did stuff on, never mind, I'll talk to you later,
Yeah,
but
okay.
it was confusing
I
because
remember
like, you
that
go into the
email.
open stacks and like it'll say, okay, this is due, but then you like go into the assignments and it's not there.
You're talking about my open math? Or your OpenStax is the book?
Or whatever, OpenStack's homework is sometimes different
Okay.
from.
Yeah, I think I need to see what you're talking about, I guess. Sorry. All right.
On that one, or are you gonna move
Yeah,
on to
I'm gonna move on.